Hi, Chem 20s. Mr. Riley here. Got my camera working this time. Just wanted to make a quick video on sort of the next progression after learning how to determine the major entities in a solution, and that is putting them into a chemical equation. And we call these equations dissociation, ionization, and dispersion equations. So let's look at each type of chemical entity or it's each type of chemical substance, and determine whether they're going to disperse, dissociate, or ionize, and then how to make the equation. Okay, so first one up here is ionic compounds. And so soluble ionic compounds are going to dissociate or split up into their ions when they're put in a solution. So let's do an example here. So let's do Mg. So let's do magnesium nitrate. So it's going to look like this: MgNO3, 2. It's a solid. Okay. Now sometimes you might see aqueous there. You know, it's kind of chemistry semantics. Is it already in the water, or has it not been dropped in the water yet? What's important is what comes on the other side of this equation. So we'll go with solid here. So what happens when magnesium nitrate gets put into water? So first, I need to determine, is this soluble ionic compound or a low solubility ionic compound? And so I'm going to go over to my solubility table. I'm going to look for the anion, the negative ion. I'm going to find it here. And I'm going to find out that most nitrates are high solubility in water. So I'm going to go back over here, and I'm going to now decide that this is going to dissociate because it's high solubility. So on this side of my equation, I'm going to start with magnesium nitrate. Okay, and I'm going to draw an arrow. The arrow, kind of, to me, how I explain that is I now dropped it in water. Okay, so I've now dropped this substance in water. What's going to occur? Well, it's going to split up into its ions. So I'm going to get magnesium ions. Okay, and if you don't know the charge, you have to do a little math with your compound, or you have to go to your table. It's a 2 positive. It is now dissolved in water, so it gets that aqueous. And then I'm also going to have my nitrate ions. So nitrate is an NO3 negative. Okay, and now the next thing I have to do is I have to balance this. And I see here this subscript 2 tells me that I'm going to have 2 helpings of nitrate ions in my products. So I'm going to put a coefficient 2 in front of my nitrate ions. And now I have a balanced dissociation equation. Okay. Now, if you have something that you find out is low solubility in water, like let's say calcium carbonate. So let's say I had, determine for calcium carbonate, okay, good. Yeah, it's still low solubility. So let's say I have calcium carbonate, solid. I determine that's low solubility from the solubility table. And so my equation would look like this. So not M. Calcium carbonate. Okay, solid, and then over here, nothing happens. Okay, now some chemistry teachers might just say, well, there's no reaction, there's no dissociation, there's no equation, whatever. You might see this also. Okay, well, we're solid on the left, we've been added to water, we're still solid because we have low solubility, we didn't dissolve. Okay, acids. Okay, so we determine our substance is an acid. And you guys can kind of see here, this is basically the same as the major entities. We're just putting it into an equation now. Sometimes we have to balance. So let's do a strong acid, H2SO4. You guys know this as sulfuric acid. You might see aqueous over here. You might see, if it's an anhydrous, dihydrogen sulfate, you might see something different. It's kind of semantics, so don't worry about that. What we're worried about is at the end. What happens when I put this into water? Well, it's a strong acid, so it's going to ionize. And I'm not going to write it again. I'm just going to go like this. I'm adding it to water. What am I going to get on the other side? Well, I'm going to get hydrogen ions. Okay, and I'm going to get sulfate ions, SO4 2 negative, right? If you need the charge, use your periodic table, your polyatomic ions chart. And the next thing I need to do is I need to make sure I am balanced, okay? And so I see here 2 H's over here. So I need a coefficient 2. 2 hydrogen ions make up for my 2 hydrogen atoms, okay, that are in that compound. And then I just have 1 sulfate ion there, okay? And I'm done, okay? If it's a, if it's a weak acid, example we used before, right? If it's CH3COOH, let's say it's liquid, okay? It hasn't been added to any water, this compound, and over here, CH3, oh my God, COOH, sorry, that's messy, okay? And the thing with this one is that weak acids are soluble, but they don't ionize. Okay, so they're gonna get that AQ there. And that's that little bit of extra that we need in terms of the detail for that one. Okay, soluble molecular compounds are going to disperse. They're just gonna spread out. Okay, they don't. There's no reaction. They don't split into ions. They don't, split into their atoms. They just spread out, okay? So for example, if I had a, let's use an alcohol here. So let's use methanol, CH3OH. So there's, and it's a liquid. And so we have to determine, is this going to dissolve? Is this soluble in water? And we have to remember the rule for molecules is that like dissolves like. And polar molecules are going to dissolve in polar water. So is this polar or non-polar? A little bit of overlap from bonding. We can determine the amount of valence electrons, draw the VSEPR structure for this, use the Lewis dot diagram to help us do that. So if I was to draw this compound, it's going to look like this, CH3, oops, oh, come on now. I was doing so well. Okay, CH, oh my God, can't draw in that spot. 3, okay, and then O, and I got these 2 lone pairs on that oxygen, OH. Now, does that look like a well balanced out molecule? Yeah, it looks like junk because I couldn't draw it very well. But there it is. It's not well balanced. It's polar. That's what I'm trying to get at. This is polar, and so it is going to be highly soluble in water, but it's not going to split up, and it's not going to really change. It's just going to spread out. So how we show that occurs is we just give it the aqueous. Okay, the only things that are going to split up are strong acids and soluble ionic compounds. Okay, so just in summary, one more time. Okay, for ionic compounds, okay, if they are soluble from the solubility table, they are going to dissociate into their constituent ions, and you need to balance that equation using a coefficient. Okay, if they're low solubility, nothing's going to happen. Strong acids are going to ionize. Now, this looks the same as dissociation, but since an acid is a molecular substance, it doesn't consist of ions originally, we use a different term to describe this. So we call it ionization. It's going to form ions when it's added to solution. And so, but it works the same as the dissociation equation when we write it. It's going to essentially split up into a cation and anions. Cation is hydrogen. Your anions are going to be some other ion, and you need to balance that equation. If you have a weak acid, it's not going to ionize. It's just going to dissolve and get that AQ. It's going to do what we call dispersion. It's going to spread out. It's going to be dissolved, but it's not going to ionize. Now, molecular compounds that are high solubility, that are polar, they are going to dissolve in water. So we're going to give them that AQ on the product side. And if you have a, let's say you had something like propane, C3H8, and this is a nonpolar molecule, then nothing's going to happen. It's going to be the same on the other side. It's not going to dissolve. It's not going to do anything. Okay, so I hope these videos help you guys. If you have any questions, you know where to find me.